So last week we spent all this time on normal curves and reading different percentages. All right. So for example, here's a distribution of male heights. Okay, and the average on this is 70. So this is n, and this would be 70, and the standard deviation is 4 inches. All right. So if I asked you, if the question was, for example, what percent of males are shorter than 66 inches? Which is 5 feet 6. Okay, so what we learned is that each one of these sections, this was 34%, 34%, 13.5, 2.35, 0.15. So if we wanted the area that was smaller than 66 or shorter than 66 inches, that's going to be this area right here in yellow. So we just add up those three numbers and that's our solution. 0.015 plus this plus 13.5. And that gives us 16%. So 16% of men are shorter than 5'6". Okay. If the question was, okay, what percent of males are between 66 and 74 inches. Okay, well, that would be this area. And we know by the empirical rule that that's automatically 68%. Okay, so that's what we did last week, using the empirical rule to find out different percentages. Okay, now what you're going to learn today is what happens when you're trying to find the area of something that's not on the chart. So if I said, okay, what percent of men are 60 inches tall? Well, the problem is there's no 60 up here. So when that happens, you can't use these percentages anymore. Okay, so when you can't use those percentages, you can't figure out, when you can't use the empirical rule, you couldn't figure out the answer to these questions. All right, so that's what you're going to learn today is, if the values that I'm given are not on the normal distribution, what do you do when they're not one of those numbers right there? Okay. Alrighty. So, if we go to the notes here, we're going to do, these are the three things. We're going to find the values to the left of a number that's not on this chart. We're going to find the value of the area to the right of a number that's not on this chart. And then we're going to find the area between two values. So to the left, to the right, and in between. And they're not on the table. They're not on the chart. Okay, all right. So we'll do a couple more examples of on the chart, and then we'll go off the chart. All right. So we're using the speed curve for a DeLorean. So a DeLorean was a car built in the 80s, way before your time. And it was a very futuristic looking car at the time. That's why they used it in the movie Back to the Future. And it was actually built in, the guy that built it was from my hometown in Ohio. His name was John Delorean. That's why it's called a DeLorean. And they wanted to build this mass-produced kind of sports car. And it was made out of stainless steel so that it wouldn't rust. And they ran into all sorts of financing problems. And he was so hard up for money that he started to sell drugs to try to raise enough money so that he could make his car. And they caught him in a sting operation. He lost his whole business. Okay, but so that's the story behind the DeLorean. There's good what do you call it? Documentary on Netflix right now about DeLorean, John DeLorean. All right, so it says once the car after accelerating for 20 seconds, a DeLorean sports car has a wide range of speeds that can be achieved depending on its traction. The distribution of the speed follows an approximate normal distribution with a mean of 80 and a standard deviation of 7.7 miles per hour. All right, so right above this curve, we're going to put N. And this curve, its mean is 80, and its standard deviation 7.7. Okay, and then we can fill in the numbers on this chart. Okay, this is going to be 80. And then one standard deviation above it, it's going to be 80 plus 7.7. So I'm going to add 3 standard deviations, plus 7.7. Okay, so that's this, 87.7. And then do it again. Okay. 5, 4. Time. 103.1. Okay, and then I'm going to do the same thing, subtracting them. Minus 7. Okay, now these first two questions, if you look at the numbers, it says what percent of the runs will give the DeLorean a speed of greater than 87.7? Well, 87.7 is on the chart. So when it's on the chart, you're going to be able to use your empirical rule. So these two problems right here, we're going to be able to use, okay, our 68, 95, 97.5% rule. Because the number is on the chart. It's on our graph. Okay, all right, so up here we know, let's see, this is 34, 34, So greater than 87, so that would be from here over. So I'm just going to add up those percentages. 13 and a half. 2.35. And my answer is 16%. So that's what you did last week. Number 3 says, what percent of the runs give the DeLorean a speed between 67.6 and 87.7? Well, good news, there's 64.6. So now I'm simply going to add up the percentages between those. So 13.5 plus 34 plus 34 equals, let's see, that's 68, 13 and a half, 81.5%. All right, so nothing new. Now the next one, it says what percent of the runs will give the DeLorean a speed less than 68.45 miles per hour? And we're actually going to do that one right here, so we got a little bit more space. It's the exact same thing. But the problem is, this is not on our, this value is not on our graph. Okay, so not on, or not a value on our normal distribution. Not a value on N 87.7. It's not one of those values that we found out. It's somewhere between those two values. It's going to be somewhere in here. Okay. All right, so here's what you do when that happens. We're going to take this score. Okay, so when this happens, what you have to do is you have to use the table. Okay, now you're like, use the table. Well, attached to the back of your paper is a table, and it's a table of z-scores and all the percentages that go with the different z-scores. Okay, so if you turn to the back real quick, there's 2 pages that got this table on it. So if you know the z-score, you can find a percentage. So for example, the first page has got your negative z-scores on it. So negative, this one is negative z-scores. Now what this table gives you is the area to the left of whatever z-score you're looking at. So let's say that z was equal to negative 1.52. So what you do is on the left-hand side, you're going to go down to negative 1.5, and then you're going to go over to the 0.02 column. Okay, so negative 1.5, that's right here. And then the 0.02 column is the third one over. So it's this guy right here. So that's 0.0643, which is 6.43%. So if this z-score was a negative 1.52, then the area shaded to the left of it would be 6.43%. When a z-score is 0, guys, it's right at the middle. It's at the median. It's at the mean. Okay? Now, if you go over here, let's say our z-score, instead of being negative 152, it was positive 1.52. Okay, so go to the side that's positive, and it might be helpful to fill in these numbers at the top. So I'll give you a second to do that. Okay, so this first one goes with 150, this one goes with 151, and this one goes with 152. All right, so that would be 93.57%. So your table always gives you the value that is to the left. Now, if you want the value to the right, okay, so if I wanted to get this instead, then what I do is I subtract my z-score from 1. Because altogether, remember the area under the curve is 1, so that would be 1 take away 0.9357 0643 0643. And that would be 6.43%. So this here is to the right. And then the shaded one here is the area to the left. So anytime it's asking you to find a probability to the right of a number, you got to first subtract it from 1, the z-score. Okay, and then the same thing's true over here on this one. Okay. This was 6.43%. So this area So you always got to know if you're to the left or if you're to the right. If you're to the right, first subtract your table value from 1. All right. So what this tells us, what we got to do is take our score and convert it to a z-score. Okay. So first of all, let's make a sketch of what we got here. So we're going to draw our graph. This is 80. And then we're looking for to the left of 68.45. So that's this little part right here. Okay, first thing, convert it to a z-score. Okay, now we did z-scores a while back. We were talking about the two different gymnasts. All right, so to get your z-score, all right, you take the value, you subtract the average, the mean, and then you divide that by the standard deviation. So that's going to be 5 minus 80 divided by 7.7. Minus 80 equals, and divide by 7.7. Negative 1.5. Okay. Okay, second step, go to your table. So you'll always hear me say table A. Go to table A. That's the table on the back. All right, so we flip to that and we go to 1, -1.5, and then 0. So that's this value right here. -1.5, and then the column is 0, 0. So that's 0.668. So, and so that's going to be 6.68%. Of runs are less than 68 miles. So that's this little area right here. So now you can find the percent of any value. It doesn't have to be one of the values that were originally on your chart. You convert it to a z-score. All right. Okay, next one. Now we're finding a speed greater than 85. So this is going to be an example of to the right. Okay, so remember, when something is to the right, you take 1 and you subtract the table value. Okay, and then everything else you do the exact same way. Okay, so we take our value, 85, we subtract the mean, and we divide by the standard deviation. Okay, we get 0.6493. Okay, now go to the table. Okay, and 64.93. Okay, 649. Okay, here's 0.6. All right, and then 4. This is as close as we can get. This is 0.64, and this would be 0.65. All right, and so if you were going to pick between these two, we're looking for 0.649. So it would be closer to this one than it would be 6.4. Any questions on that, guys? How this one's 0.65. This one's 0.64. The 4.9 would be closer to the 5.0. So that's the value from my chart, and now I'm going to subtract that from 1. So 74.22. So this was 0.7422. Okay, and now 1 minus that. Point 2.578. And that's our percent. Okay, now the last one, you've got to find it's between two values. So I'll give you a second. Let's see. 94 minus 80 divided by 7.7. Okay, so this one is 194. Okay, and we're going to go to the table. And we're going to get that number. So 194. Oh, actually, if I rounded this should be 195. Let's do that. 195. Okay, and now we'll go to the table. 195. 195. So positive 19, 190, 191, 192, 3, 4, 5. 97.44. Okay. 0.9744. Okay, and then I'll do it for the smaller one. 70 minus 80 divided by 7.7. And that's negative 1.3. Okay, we can find that on the table. -1.30. So 0968. Okay, 0.0968. And now what I'm going to do is subtract these two. So let's see, 9.9744 minus 0.0968. And there's your percentage. Okay, so all we're going to do is just summarize these three things, and then that's it for today. We'll finish these tomorrow. Okay, so we got to the left, okay, to the right, and in between. Oops, undo that. Okay, oops, darn it. Okay, and the first one, your area is the same as the table value. Okay, the second one, your area is equal to 1 minus the table. And then the last one, you take the bigger one and you subtract the smaller. Okay, so I'm going to do the table value for Z2. Table value for Z2, that's the bigger one, minus the table value for Z1. And that's how you do your three percentages. All right, tomorrow, blood cholesterol levels for teenage boys. And your cholesterol level is an indicator of possibility of heart disease in the future.